Twist drills work by shaving their way through the metal. They have two cutting edges that do most of the work, and that don't actually intersect each other, but are connected by a chisel edge at the tip of the bit. The bits have flutes that spiral up the shaft to the solid shank, and these flutes work to pump the metal shavings made by the cutting edges up the bit and out of the hole. Bits are measured with several different systems: fractions of an inch, decimal inches, millimeters, letters, numbers, and because we use very small bits, we use a system referred to as numbered bits. We measure them using this gauge plate. It shows the number and equivalent in decimal inches. If it seems confusing, remember that we're only interested in the whole numbers. This large gauge plate measures bits 1 through 60. And because some of our bits are insanely tiny, we have a second plate for numbers 61 through 80. When using this tool, insert the solid shank into the holes until you find one that fits snugly, but the next hole smaller won't pass the bit. Larger bits are usually marked on the shank with its size and the material it's made from. Our bits and gauge plates live by the drill presses. Small bits that match our wire sizes are stored in the small chest of drawers. The cutting edges of a twist bit don't actually come to a point, they meet in a chisel tip. This means that if you run these on metal, they'll spin and walk around the surface until the chisel tip gnaws its way deep enough into the metal for the cutting edges to bite in. This walking is easily avoided by center punching your metal before drilling. This makes a dimple in the metal's surface that catches hold of the bit's tip, keeping it from walking and bringing the cutting edges into contact with your metal. We have a couple ways of center punching. The point of your scribe can be placed where you want to drill and then tapped with a rawhide mallet or chasing hammer. Make sure to do this with your metal on top of a bench plate, not a wooden surface. We want a dimple, a deformation into the thickness of the metal, not a dent, which reshapes it more dramatically. Near the drill presses, we also have auto punches, which are spring-loaded so you don't need to hit them with a hammer. Just put the tip of the punch where you want to drill and push down until it snaps. An internal hammer drives the tip of the punch into your metal. Again, do this against steel, not wood. The auto punch is very aggressive and it will make a huge dent if not supported by steel. Also note, you're not trying to make a hole through the metal with the punch. That's why we use the drill. We have three options for drilling a hole in our shop: a full-size drill press, which we're not going to cover in this demo because it's not appropriate for the kinds of things we make in this class; two do-more sensitive drill presses, which are excellent for use with small, fragile bits and for when the hole you're drilling has to be perpendicular to the surface; and flexible shaft machines at each of your workbenches, which are harder to control than the do-mores, but more convenient and versatile. Start by turning on the light. Press and hold the red button until the light starts up, then release it. A do-more sensitive drill press has a platform that holds your work and raises it to the drill bit. They're called sensitive because the platform is raised by a knob that you turn just with your fingertips, allowing you to feel the pressure that you're applying. This makes it very good for working with small drill bits that will break if too much pressure is applied. The knob at the back allows you to adjust the height of the platform. The power controller for the drill is a foot pedal. The switch on the side of the motor is a shutoff for the foot pedal. The do-mores and flex shafts both use a Jacobs chuck. These have three jaws that are moved closer together by turning the outer sleeve. On the do-more, that can be done with your fingers, but both need a chuck key to tighten the chuck enough to drill with it. Insert the bit into the chuck and close it until all three jaws surround the bit. Make sure the bit isn't stuck between only two of the jaws or it won't spin on its axis. Insert the nub at the front of the chuck key into one of the holes in the chuck. Lift up gently on the key to mesh the gear teeth and finger tighten. Repeat with the other two holes. Place a wood block on top of the platform to protect it. Loosen the clamp at the back of the platform structure and adjust its height so the tip of the bit is within a 1/4 inch of the surface of the sheet. Lubricate the bit by drilling into a stick of burr life. Line the metal up with your bit, and running the drill slowly, raise the platform till it gently touches the dimple in your metal. If the bit diverts or moves to meet it, adjust your aim. Firmly grip the metal to the block and platform. Increase speed and gently touch the bit to the work. Increase pressure until the bit begins to visibly create chips or shavings. Use only as much pressure and speed as needed. Periodically ease off on the pressure to allow the bit to straighten out, eject the debris from the hole, and for lube to seep into the hole. Continue the process until the bit breaks through. When you're finished, put away your bit. The flex shafts have a motor and chuck very similar to those on the Dumors, but they're connected by a flexible cable that transfers power from the motor to the handpiece. This allows you to use a variety of sanding, carving, and drilling tools. The motor on the flex shaft is reversible. And like the Dumors, it's controlled by a foot pedal. The chucks operate the same way they do on the Dumor, although the guard around the chuck's gear teeth makes it necessary to do all the adjustments using the chuck key. Lube your bit, center punch your metal and place it on top of the bench pin or a block of scrap wood, and hold the handpiece as vertically as possible. Start the bit turning and gently touch it to the work. Increase pressure until the bit begins to visibly create chips or shavings. Use only as much pressure and speed as needed. Periodically ease off on the pressure to allow the bit to straighten out, eject the debris from the hole, and for lube to seep into the hole. We never drill large holes in sheet metal. Because the bit shaves its way through the metal and is conical in shape, it removes more and more metal as it penetrates deeper. And you're holding the metal down by hand, so you're having to resist the bit's attempts to simply spin the metal instead of cutting it. The bigger the bit is, the more exaggerated this becomes, because it's removing more metal at once, and it quickly becomes impossible to hold on to it. The solution is stepping up. You start with a small hole around a 55, and the bit you wish to finish up with, up to 1/8 of an inch. Then pick 1 or 2 bits in between those two sizes. Drill a pilot hole with the 55 bit, then use each bit in succession to widen the hole. Each takes away a small amount of material that is still within what can be held down easily.
Doesn't have to be continuous.
If the bit isn't cutting, or it stops cutting, something's wrong. Don't try to force it to cut by using more speed or pressure. Bits can be damaged in a number of ways that make it impossible for them to cut. If yours isn't cutting, try another bit. Discard the bad bit. Many of our bits are quite small, and the bits have cutting edges that are very fine and can be ruined in a number of different ways. When you're selecting a bit, take a close look at it. The tip should be symmetrical and geometric looking. If it looks chewed up, rounded off, or jagged, it's trash. Sometimes, even with precautions, a bit still takes too big a bite, especially as it breaks through the last metal at the bottom of the hole. The burr grabs hold of the bit and spins it out of your control. You can reduce the chances of this by gripping tighter when you're almost through the hole and using a little more speed and pressure at the end. Larger bits tend to scream as you drill, as the bit vibrates or chatters while it cuts. To fix this, use a little less speed and a little more pressure. Most people use far more speed than they need to. Another problem that comes up occasionally is melting the tip of the bit. Often if a bit stops cutting or fails to cut in the first place, people try speeding up or pushing harder, often both. And steel is a poor conductor of heat, so all that speed and pressure is just going to be turned into friction trapped at the very tip of the bit and melt the cutting edges right off. If your bit isn't cutting or your metal is getting hot, stop. Check the tip of the bit for damage. Make sure that the flex shaft is set to forward. And finally, check for pimples. Sometimes the metal at the very bottom of your hole deforms outward instead of cutting away or bursting, and it shapes itself so perfectly to the tip of the bit that the cutting edges aren't in contact anymore. The drill becomes a fire starting tool like a bow drill, and making the bit spin faster or putting more pressure on it will just ruin the bit. If a bit that had been cutting normally suddenly stops cutting, stop. Flip over your piece and look for a raised bump like a pimple. Use your scribe or center punch to pop the pimple and finish drilling from that side. While we're on the subject of drill bits, I'm going to share with you one of my pet peeves. And here it is. When you don't put away your drill bits and you just toss them in a pile, it makes it very, very difficult for anybody to find the drill bit they're looking for. And it just takes a second after you're done with the drill bit to figure out where it belongs. It has markings on the shank. Who knows whether I'll be able to focus in on those or not. But it has markings on the shank that you can look at and then find the appropriate hole in the index to stick it back into. If the markings are worn off or chewed up or you can't find them, you can always use the drill gauge that I showed you earlier so that you're doing your part to help keep things tidy and organized. Part of the reason that makes me upset when I see big piles of drill bits like this is that somebody's going to have to go through and put those all away at some point. And that someone is not going to be me. It means I have to find somebody who deserves the job to give it to.